Hello everyone, I am Kanav Gupta, a third year student in engineering physics at IIT Roorkee. I have done this machine learning project of customer churn prediction under the supervision of Professor Mayan Goswami. So thank you sir for it. So this project is for predicting the customer churns and it leverages machine learning to improve customer retention. So I'll just talk about this project and why I've done this and what all I'm going to do in this video PPT. So this video PPT will have a brief about this project, why this project was necessary, and then I'll go on to the data which I've used, the data sets, and then how I have used that data to make an analysis and how I've created a machine learning model. And with that, what is the accuracy I came, what is the test results of it, and hence what are the applications of this model in the industry. So this is what this whole project consists of. The tools which I've used are the Python, of course, for the coding. Then there's Pandas, which is to look upon the data. Then there's NumPy, there's Matplotlib for all the plotting work of it, and there's TensorFlow and Keras, which is for the machine learning portion of it. Now, customer churn prediction. Customer, we all know is customer, but what is churn? So churn is a business term which is given to the customers who stop availing a services. For example, if I am a customer of a business but I've stopped availing the services, then I'll be a churn customer. So predicting that which customers are about to churn out or which is the more portion of customers which churn away, that whole prediction and that analysis is what this model does. So what is the business problem? So the business problem is like this whole thing, this project is for the telecommunication services, and that's the data which I've used. Hence, I've even put in the photo of the telecommunication services. Anyways, yeah. So what is the business problem of it? Why do we require it? The point is that telecommunication services, this whole industry, has an amazingly intense competition with many players in it and very competitive pricing. For example, if I talk about mobile services, we have Airtel, Geo, Vodafone Idea, BSNL, and many services. For example, and even in TV services, we have Airtel DTH, you had Tata Sky, we had cable services, maybe we had unlimited options. So that's the point of it, that there is a huge option which a customer has, and they're of course intended or they're inclined to go towards a service which provides them the best services in the least amount of money. So hence this industry has an intense competition, and the customers, they were switching frequently, and which created a significant pressure on these companies to reduce churn. And there is economics, the money factor to it as well. I'll come on to this later on, what this thing signifies. So the point is that we have a lot of data, we know our customers are churning out, we what can we do? So this is what this model does, is we can analyze that which are the customers who are churning out, which is a major segment of the customers who are churning out, and can we create a model which tells the companies beforehand that at this stage of time these are the customers who are more intended to churn away, so that we can focus on those customers and improve their experience with us, so that they stay with us and they don't churn out. Now the problem is, what is the problem in churning? I mean, why does customer churn matters? Because clients are coming, customers are coming, customers will go as well. Then what's the issue? So the issue is that this industry has a churn rate of 25, 15, 25%. What churn rate means is, for example, if there are 100 customers going, but and that same month there are even like 20 customers existing which are going away. So I have 100 new customers, but 20 customers are going, which means my churn rate will be of approximately 20%. So the point is, in telecom industry, we have 15 to 25% of a churn rate, which is a very massive number. A churn rate of about 3, 4, 5% is still okay. Means that as well is not good. Even their customers or companies hope that the churn rate is as low as even 0%. But of course, that's not ideal. That is an ideal thing, but it's not practical. But even like a 5, 6% is still okay. But in this telecom industry, the baseline churn rate which happens is about 15 to 25%, which is a massive number. The point is that cost multiply for retention. So actually what happens is that retaining a customer gives you 5 times more profit compared to acquiring one. Or if I'll say in other words, the money which is required to retain a customer is 5 times lower than acquiring a new one. So acquiring a customer, the customer acquisition cost, the CAC, which we call. So getting a new customer, the money which is spent into CAC to get just one customer is much more, is 5 times more than actually the cost which can be invested on just to retaining an existing customer. And studies show that even a 1% reduction of churn leads to profit of 10%, which is a massive thing. Why? Because that existing customer, you don't have to spend CAC on it. You don't have to spend on marketing advertisement for that existing customer to be retained with you. And Upar say, if there's a customer which is retained with you, they have a trust built on you. So you can even try cross-selling them some new other services of yours. For example, if I'm a customer of Airtel and I have a good service with them, a good experience with them, and I am happy with the customer service. So if even if they, for example, if I want to get a TV subscription, there's a high chance instead of Tata Sky, I'll be preferring Airtel DTH because I have a trust in Airtel. So those are additional profits in their existing customer they have. So hence the profit impact is approximately of 10%. And hence this is a very big issue which customers and businesses focus, and hence it's a strategic focus which businesses focus on to predict churn and to understand which is the customers of there which are facing an issue, and how do we run targeted campaigns which retain these customers and which protect revenue, and of course which strengthen the customer relationship so that the customer has a good relation with the business. So this is the end of the first part of the video which I am making. The next part is on the data set and the coding part of it. Hi guys. So that now we have discussed why the churn matters. This is a part two of the video which talks about the data set and the coding part of it. So here is it. So this is the data set. So the data set which I've taken uses the telco communication services. It's a telecom service company based out of Massachusetts, US. So it's the data which they have uploaded on Kaggle. So it has approximately 7,000 customer records. I'll show this data to you, of course. So it has these data with the the behavioral and demographic attributes to it, which are like gender and senior citizen status. If they are a senior citizen, yes or no. What are the dependents? Do they have a partner? If they're family members, what is the contract type? What is the tenure they have stayed in the service? What are the way of payment for them? Along with the service and the financial data, like what is their internet service type? What are the phone services or the streaming services they're using? What are the monthly charges? And till date, what all is the amount they have spent in the company? So these are all the elements we have in the data. So I'll just show you a quick look. So these are the data which I have, and there's approximately 7,044, anyway, 7,000 plus data which is there. And for each customer, there's a data of customer ID, which is of course, which won't be useful for us. If their gender, what is there? Is there a male or a female? Is a citizen, yes or no? Zeros are no, ones are one, yes. If do they have a partner or not? The dependents in the family, like are the people who are dependent on them, yes or no? What is the tenure? Like how many months have they stayed with the business, or since how many months have they been availing the services? Do they have phone services? Yes or no? Do they have multiple lines? For example, if someone has no phone service, so it doesn't make sense, of course. Then there's internet services. Are they obtaining or they using internet services? Do they use a fiber optic or DSL, or they don't even use an internet service? Online security, of course, if someone does not use an internet service, they won't be using any online security. So no internet service, no internet service. But for the others, like do they have internet online security? Yes or no? Online backup, device protection, tech support, team streaming TV, yeah, means like TV streaming services, OTT services, and those all things. So these are data we have. Then for contract, it's like 1 month to month, yearly basis, or a month to month basis, or 2 year basis. So it's that thing. Then paperless billing, that is their paper letter which they'll receive at home, and they'll accordingly pay it. Like do they need a physical receipt or not? And then the payment method, either it can be an electronic check, it can be a mail check which they post and mail. Then it can be a bank transfer which is just automatic, like on a recurring basis. Then a credit card, we have many things. And then monthly charges is like on the basis of what all services they have taken, what is the amount they are paying, and that multiplied by, of course, the duration they have stayed comes out to be roll charges. And then finally we have churn, which is yes or no, that are have they churned or have they not. Yes means that this customer is no longer with us, and no means, of course, that they are still existing with us. So this is the data. So the methodology or this which I made is our 5 step one, which includes the data cleaning. So I removed all the missing values which are there, like the blank values. I removed them all. Then there are values which are not required. For example, customer ID won't give us any use, so I've removed them, and those are things. Then there's feature encoding, which is like, for example, there are zeros or ones is fine, point values. But for example, gender is male or female. So the model won't be able to understand male or female. So converting that male and female to zeros and ones is what we encoded it. Then we have model design. So this is the main machine learning part of it. and then we trained the model. So while training it, we had 80% of the data which we kept for training, and 20% was a test data on which we further evaluated using accuracy, confusion metrics, and F1 score metrics. Hence, now I'll show you the code which I made. These are all the libraries I uploaded. Then I loaded all the data, and again, it's the kaggle.com data sets, which is telco customer churn, which is public open source. You can as well download and check it out. Then there's I showed like this is just to show you that this is the same data which I'm using. 7590 VHVG 7590 VH. Yeah, this is the data. These are the top five rows and the 21 factors on which. Then this is the cleaning data set. I dropped the custom ID because it's of no use. And then there is the data types. So we have object in 2064. So all the numerical values, like for example, senior citizen has a numerical value 10 year. So these are have to be in 64. So senior citizen tenure, these are all in 64. Other values are object values. But the point is monthly charges is float 64, but total charges we saw, I realized that total charges had to be integer only, but they are object. So I again just checked all the values and I just printed them. So as you can see, it's an array of these numbers. They're meant to be numbers, but still the data type is an object number. So this was an attempt to convert them to numerical values. So firstly, I just converted all the values and then I changed them to float values. It didn't turn into float values. So as well, I later on did this conversion and hence finally got them into float 64 values. So on total charges, we have float 64. This is the whole thing which we did. And then next part came of visualizing the data. So this is a visualization of the data which shows the number of customers with respect to the tenure. So this shows that with tenure ke basis pe, the customers, how many customers have churned, how many have not. So green is yes, basically, but we want the customer should not churn. So the green is actually the bad thing in this. So we just recognize that in the early tenure of it, the customers are churning, but as we go on later on, customers not churning. And those customers who have a tenure of 70 months, 64, 12, 60. Yeah, I mean like 5 years, 6 years, they are not churning. There's only a very small percentage of people at that time who are churning out after that duration. What can be the reasons? But the point is like in the initial months only are the customers are churning. If not, then they stay a loyal customer. Then this is on the basis of monthly charges. So in this we can see clear trend, but in monthly charges there wasn't a clear trend to be very honest. But we saw that the less cost one of it, there was a very small churn rate, which is a good thing. Means in the economic part of it, the customer churn rate is very low, which is a good thing. And then hence the data. And then now the point is like I was just trying to inculcate all the unique values, and this is what I printed. So for example, stream TDV, either we have no, yes, or no internet services. For contract, we have month to month, 1 year, or 2 year basis. These are all those things. So yeah, no internet services. We don't need no internet services. I mean, why should we put a third variable? We just need binary zeros and ones. So no internet service and no can be actually said as the same thing. So hence this is what we did, that replace no internet services with no, and replace even in phone services no phone services to no. So this is what we did, and finally we just got yes no yes no yes no yes no. This is what we did, and then these are the columns. So we printed the unique columns, and yeah. So basically every column has a yes no. So this I just wanted to see which all columns have some unique values. So gender had male or female. Internet services had a DSL fiber optic or no, three values. Contracted month to month, 1 year, 2 year basis, and all. So this is what we had. Now I have started converting or encoding these values, one hot encoding, that I replaced female with one and male with zero. So this is what we did. So one zeros, it hence did not come into the unique ones. So this is the one hot encoding for the categorical column which we all did. After which all the data types came into in64 or float 64 values or boolean values, which is what we wanted so that the model can understand them. Then we scale the data, of course, and then there's the training test split. So in this, like the test size is 0.2, which means the training data I kept it to 80%. So 80% was the training data, 20% was the test data. So this is the model which I ran, and this is the classifier model which I ran, which made all the analysis of it. The model was trained, and finally the output was predicted. So an output getting zero means the churn is not there. If it is one, means the churn is there. So this is the result which we got. Now, next comes in the evaluation part, which I'll continue in the next part of the video. Hi, so this is the third part of the video. I'll just run the code once again in front of you. Yeah, so Just a second. Yeah, the code has run. So till now we just saw the predicting the output part. So now is the performance metrics of the code, that how the code has performed. So I just checked an accuracy of it, that how accurate is it. So the accuracy came out to be 80%, means the code predicted up to 80%, that which are the people who are most likely to churn out, which is a pretty good number that we are able to figure out, that we can predict up to an 80% accuracy of it. And yet there are some other metrics as well, such as precision, recall, F1 score, and the support which is there. So yeah, the data are in front of you. So an accuracy is approximately of 80%, and the macro average of 76, 73, with F1 score 74, and the weighted average of 80%, 80%, 80%, which is, in my opinion, a very good, fair number. Then this is the truth chart which I made, which is there. So this confusion matters. This chart is basically, yeah, the heat map which is there. So the heat map with the low numbers being in the darker color, and the bigger numbers being in the lighter colors of it. So I can see, as you can see, this is just a number that the predictive value, if it's zero for the churn and the truth rate to be zero, means we predicted that they won't churn and they didn't churn. We predicted 892 was alright. 179 we predicted they would churn but they didn't churn, which is okay. And then we predicted that they will churn but they didn't churn, that is 107, and we predicted would churn and they did churn is 29. So in all these things, the value which should have been least is that we predicted that they would not churn and they churned, that is 0 1, this thing, which is still a number but it's still a lot less number, which is a good thing. So this is the whole values of it, the whole uh, test of it and the results of it. So coming back to the PPT, so this is the evaluation which I just showed you guys and everything code of it. So what is the proposed solution? Means these are the aspects which I just wanted. Means this is something which you did for a client. So hence the proposed solutions. So the point is exactly as we saw. Means this is just a reference to show you how this code actually will work in the industry. So we could see from this analysis that the monthly charges on the low thing, it's no, so it's a good thing that new customers with minimal service history show elevated churn risk, right? And then price sensitivity correlates with increased likelihood to provide a such chain. Of course. So in the lower monthly charges, the churn rate is very low, means like people will tend to continue. But as we go on ahead, the monthly charges as they increase, there's a higher chance of the customers to churn out into other services. Then there is the plans, month to month plans as well, which I recognize was there as we discussed. So, in the month to month plans, what happens is that they get a more flexibility. So they have an idea. So, like a month to month plan gives them an illusion of free will, more free will compared to a longer term commitments of 1 year or 2 year. So it turned out that month to month plans were actually having a low exit compared to long term plans. So maybe we can just figure out which are the people who have long term, who are on a long term subscription, which are on a higher monthly bill and are at a lower tenure, means they have a higher risk of churning out. So that's the point. So this is the key results and insights that, okay, the presentation will come, but yeah, this is the model performance. And then the business benefits is that the company, for the company, the benefit of this whole thing is it reduces the customer attrition, means like just predicting it, so it reduces the effort which is required to understand from the consumer that where the issue is. And it enables the company to give personalized retention offers and campaigns. For example, we can figure out that these are the people who are having a high chance of churning out, we can give them some personalized offers and campaigns can be run. Then it improves the long term revenue for the company, because we can understand that who are the people who are going to churn out, and it gives a better predictability and stability for the company. This whole thing optimizes retention, of course, and marketing spend allocation, which we discussed in the previous slides. That CAC, the marketing spend, means like retaining is 5 times cheaper, economic than actually getting a new customer. For the customers, it's that if we can see there's a trend, or the customers know that there's an issue in this type of services, the companies will recognize that, and the customers will get tailored services which will have the plans which match their own needs. Then, of course, they'll benefit from the timely support. there'll be an improved satisfaction, obviously, because wherever the issue points are there where the customer is getting unsatisfied, they're exiting out of the service. So but since now we'll recognize that which are the issues where the issue is there, so they'll get an improved satisfaction and they'll get access to targeted loyalty incentives. So this is just a sustainability part of it, means like other than this telecom industry, which are the other industries as well where it can be scaled and the cross industry applications. So banking as well is a sector where this can be implemented. For example, some loan services or some financial services, e-commerce, like which are the people who are opting out of, maybe like for example for the services, for example, digital electronics is something people are not using Amazon but they're using Flipkart. So Amazon will focus on their electronics items. And for example, on the contrary, maybe Flipkart recognizes that people are buying clothes from Flipkart, but they're using it from Amazon or something, or from other services comparatively. So they can focus more on their clothing part of it. Then streaming platforms means, yeah, telecom services at today's date in the TV services. Instead of that, it's come on more on OTTs. So Netflix, Amazon Prime, these all can use this same model to understand that which are the customers who are going out. For example, are there elder customers who are churning out? Are there the younger generation who are churning out? Or which are the genres of movies in which the people are churning out? So hence, this is the future scope of it. That how can this model, what is the future scope for this model in itself, is that of course that this model can be enhanced further on. The accuracy is 80%, so with more amount of data and more precision we can increase that to 90%, 95% as well. And then operational integration means like just making a model won't be sufficient in itself unless we take a step ahead and we integrate this model into actual business and actual CRMs. The thing, and of course, if we can have real time deployment, which is where it is in live action, with the customer relation teams are actually looking into those things. That okay, these are the people who are churning out, and they act upon it, and where an actual implementation of this model can be done. This is the thing, and hence the key takeaway of whole of it is that machine learning transforms this churning from a reactive problem to a strategic opportunity for the companies. Means the reactive means we are just seeing, oh, the churn rate is down, is high, so we'll have to work upon it. So instead of a reactive problem, means like once the damage is done, then we are reacting. Instead of that, it is a strategic opportunity where the companies can master on this thing and they can use it as a strategic opportunity to gain a strategic edge over other companies, and they can predict that who are the customers who are going to churn out and they can focus on them as well. So yeah, and then of course predicting the risk before it manifests, before that risk actually happens, and then businesses gain the power to act intelligently, and then this strengthen the customer relationships and protect the long-term revenue growth of this. So by which customers can 2x their revenues and increase their revenues as much as they want. And yeah, this is what the whole model is. So thanks a lot for this, and thanks a lot, sir, ma'am, sir, for this opportunity. Had a great time interviewing this. Thank you. And yeah, again, just one thing I'll have to say means why this, because businesses is something as well. Personally, I'm interested towards, and I will want to work into. So hence, this is something which I found was more relatable for my domain of work. But yeah, of course, using machine learning in it. So thanks a lot. Kanav Gupta here, signing off.